Welcome to Talking Tuesday. I am your host, Fancy Quant, and today we're going to talk about manufacturing as part of this series of getting down to business here. So let's just start off with talking about basically my favorite process of this. So for me, I worked on the entire process for manufacturing. So when you manufacture precast concrete restrooms and facilities here, there's kind of three stages here. You do the casting, which is more or less you set up forms on flat tables. Again, we have textures. There's textures in these forms. You set rebar in, you set all the embeds in. That's how the walls get welded together, is through embeds, and that's how you lift products as well. And then you pour everything, and then it gets stripped, and that goes to the second phase. So after it all gets stripped, there's assembly. So someone has to have a crane, you have to have a welder, and someone to help you direct panels. So think about setting like a massive concrete slab as the floor, and then somebody's going to be pulling these panels, which are walls, and they set them all up. You have to make sure they're square. We had massive steel supports to set all these walls in place and hold them. And then once you got them exactly how you wanted them, we'd weld everything together. You know, you put the roofs on, you weld those in place and everything. And then the final process here was doing the finishing work. And the finishing work was going to be like painting, caulking. If there's any stone on the project, so we would do stone, veneer stone. You would lay all the stone on the building as well. You'd hang doors, locks, again, painting, install windows, signs, for example, grab bars, all that type of stuff. So my favorite process was laying the stone. One of the reasons for that was when I would do it, we used to pay a company to do it. It was super, super expensive. And this will go into the operations side of this discussion here. But we would pay someone to do it, and it was really expensive. And then all of a sudden, they'd want to get paid like before they did the project, or they'd want to get paid right after they did it, like within like, I don't know, a day or something. And a small business doesn't have that sort of cash flow. So we weren't able to do that. And then we had, a lot of employees do it. And we went from paying, I don't even remember. I think the original guy we paid like $1,000 or $1,200, maybe it was $800 to $1,000 to do for a project. Again, that's no materials. That's just the labor to do it. And then we would pay our guys to do it. And a lot of times it would come out to like $2,000, $3,000, $4,000 to pay them to do it, and just the labor, because you have too many people and they'd be screwing around and it just wouldn't get done. And I actually offered, this is a story kind of was somewhat, the president didn't want me to do the stone. I didn't know what I was doing, right? His employees were great people. And so we always had this debate over, I could do the stone and I can do it for a lot cheaper. And so finally, it came down to like, okay, fine, you can do the stone if you do it for the set price that we were paying someone to do it, $800, and I'll pay you when I get around to it. It's like, awesome, let's do it. So we did it, we laid the stone. I did it, I believe, with me and a partner, so two people. It would take a total of 8 hours, which is like nothing. You think about hours, hourly rates, how would you get to $3,000 on a project? You're paying guys like 12 to 16 bucks an hour, and some of them are making, I don't know, $20, $24 an hour, something like that. Again, this is many, many years ago when minimum wage was even lower. Minimum wage in Washington State, for example, in Idaho where we were working, was, again, far, far lower than what it is today. But we would pay all this, you'd figure out how many hours it was. So I just knocked this out of the park. Our president came and looked at it. Of course, he was like, well, there's some, stuff you need to touch up and whatever. But then he realized, like, okay, it's far cheaper to pay $800 for one person to do it versus, paying an entire crew of people to drag it out, or having the other guy who demands to get paid instantly, basically. And so for me, I love doing the stonework because it was really a solo job. My wife actually came in and helped me a lot of times. So we would do it as a team. We'd lay out, my wife would help lay all the stone out. We'd mix all the mortar. I would start laying stone and get rolling once we had everything set up. And then she would usually start on the other end, and we just lay an entire project and get it done. So it was a lot of fun. But from this example, you can see that the operations component, which I think a lot of the precast concrete industry as a whole is completely missing here. And I'll explain why here in a second, but they don't understand the cost and how to control costs. And a lot of times I don't think they're actually tracking all of their exact hours. And I'll explain why this is important here. Most precast concrete companies essentially do forms. So I'm gonna call them bucket forms, for example, to just give you kind of that mental image here. A lot of them will pay for some sort of form here. So imagine doing, I don't know, like doing pipe or doing vaults or doing a variety of things. There's a specific form for that. So when you do vaults, for example, it's an easy example. It's basically like a bathtub form. So think about it like that. It's like a giant square bucket basically, and it has the shape inside. And a lot of these have sides that actually unhinge. So you unhook the sides and all the 4 walls fold down, and then you can assemble all your rebar for structural strength in the inside. The guys tie it with wire, then they move on and they grease all of it. You grease all the forms so it'll actually pop out when you pull it. And then you put all the walls up, you can grease it, whatever, spray it all down. And then they just get the mud and they dump the mud in the form. You wait until it gets hard and you pull it. And you're basically done. Like, that's the process. A lot of that's super simple, but a lot of them aren't actually tracking, for example, how efficient are they at it? Or perhaps a lot of the casting on this side is so simple and so mundane, they've got it down, I'm not going to say to a science, but they've got it down to a lazy, comfortable pace where you're just pouring X amount of volts per day or X amount of feet of pipe per day, for example. And that's really precast in a nutshell. So it's not really exciting. And one of the issues I see though a lot is they overhandle products. So this is coming from the operations side of, when we started trying to get other precasters to be licensees, for example, and you try to bring in different corporations, you're like really excited, something completely new, a different product, like we're super excited, we love what we make. But again, we were running low on cash flow and everything, so we got out of the manufacturing side. And so you try to help these companies explain how to make more money doing it, right? And it seems really counterintuitive, like, oh, you weren't successful at it, so why are you giving advice? But I'll show you here where you can save some money and why most precast concrete companies, are basically just dead. So industry-wise, it's a dead end. There's nothing there anymore. And then also how they can innovate and do things differently, right? That's where a lot of these companies want to get, but they just don't know how to get there. So using restrooms as an example here, the biggest, most competitive business, the one that, our president built in the past, that whole building division, industries, I don't know, leading name, biggest producer, all that stuff, at least back in the day. When they set it up, so our president set it up so that it was essentially an assembly line, and they ended up doing a bunch of crappy yard setups and finally convincing the corporation to spend a bunch of money and get a really nice manufacturing setup. So this is, I think, the most optimal setup possible, and I'll talk about it. It's really expensive though. They had a long building and it had rails through the middle of it. So I remember as a kid actually going to the plant and standing out on there and like hopping up on the buildings that were on the rails. But it was a set of railroad strips here, right? The rails for the actual railroad cast into the floor of this building. And they would take rail cars that are flatbeds and they would essentially build everything on it. So you would cast all your panels on the side. So for example, you'd cast the floor first and you'd set that on top of the rail car. And then it would slide down a little bit. Then they would take all the walls that they already built, again, cast it on the side. They'd pick all those up and set them onto the building and assemble it. And then it would slide down to the end where you had the roofs, and you'd strip the roofs and put those on top. And then the best part of this, right, you slide it down a little further, and the guys in the finishing crew could patch all the bug holes in the concrete. And then what would happen is they'd slide it in once it was finished into the final stage here. So there's a bunch of other stuff in here. For example, like caulking and doing grout keys and stuff like that. But you'd slide it into that final spot, which was a paint booth. And they could seal it all up, meet all OSHA requirements, environmental requirements and all that. And they'd have a guy go in there in an entire suit and everything with an air gun, and they'd shoot the whole building and be in and out, super quick, right? Not a big deal. You get in, you get out, you spray it, you're done. So a lot of times the roof is a different color than the walls. And of course, later you have to hand roll all the floors because it has sand suspended in it. So a whole other process here. And then you roll the metal and all that, but I'm not going to go into that. But you get it done, and then you'd slide it out the door, or you could slide it towards the end, and the finishing guys could finish it in a nice, warm, conditioned environment. So they're pouring these, in the winter, I don't know, it's 25 degrees out. You can just roll these buildings through an assembly line style. It's super, super efficient. From an operations standpoint, it makes a ton of sense to do this because you can have all of your materials as well stored in those locations. So one of these issues is going to be getting your materials to that location. So imagine you're doing casting. What do you need for casting? You need a lot of rebar and a lot of embeds. And there are specific embeds that only go in floors. There are specific embeds that only go in roofs. And the majority of embeds for walls are all shared together. So you could basically have, right, your floor, your walls, and your roofs down the assembly line where you're stripping from the forms and pulling and setting them up. And you could have all the parts and materials stored next to those forms. So it's really easy to set up stations because you have to cut all the rebar by hand. You can use a saw, but you cut it all down. You can use lock cutters too, we did that a lot. You cut it all down and then you throw it into the forms that you're at. So the materials are close to the forms, there's not a lot of walking, there's not a lot of moving. It all goes in this nice assembly process. I'll give you now kind of the cheap man's version, right? When we ran this, and we ran this in different yards, we went for the spoke and hub, or the hub and spoke kind of design here, because we didn't have all that material. And you could do it with like maybe a semi-truck, right? You could build it on there and you could pull a trailer through instead of having rails. Again, it's going to be a lot higher off the ground. You have OSHA concerns, you have safety concerns of getting up and down and off and on. So again, a truck's not really the most optimal. You need that rail system, but you could do a truck. But the issue with that, again, is you have to have a really long space to do it. And then again, you'd really want something covered. We didn't have all that. We were just pouring in fields, right? There was a plot of land. We needed to use that plot of land. And so what we did is we did this hub and spoke where we'd set up a spot basically, and we'd think about this methodically. Where does the crane going to go? And you think about where the crane's going to go, and then you think about, okay, we want to pick and assemble this whole thing, the whole building, in the middle part, where that hub is. And so the hub's going to be the assembly location as well as the crane. And a lot of times you want to do multiple buildings, so it's kind of like a oval, think about it as an oval hub here, right? We want to be able to assemble 2 or 3 buildings side by side. We don't want to remove the crane a lot. We want to park the crane, be able to pull all the panels, assemble one, pull the panels, assemble a second one, and do a third one. 3 is pretty optimal for a small kind of startup here. And again, if you're larger too, you don't want to have a lot of space for assembling buildings because you want to get one in and one out and be done. But that was crucial. So we'd set it up so you'd have it assembly and a crane all in one spot. And then around the outsides here, we would have, right, think about these as like the spokes here. We would have all these panels where we would cast them. So you'd cast, the floors, the walls, the roofs, everything, even vaults, for example, we did vaults as well. And then you'd pick it all up with the crane, and hopefully you wouldn't have to move. A lot of times you have to move it a little here, a little there, but you move the crane and you pick all the pieces up and then assemble it in one spot. Okay, so this is the crucial design here. When you look at a lot of precaster though, the other issue they have is moving product again and again and again and again. And it doesn't make a lot of sense to do this, and they always argue with you and say, we don't do that. And yet you can watch it and it happens again and again. So what they do, they'll lay out like a square, like a grid format instead, and they'll cast, a wall here, a floor here, a roof panel here, and it's all kind of mixed up. And then they go and they pick up all the panels and they say, oh, they're in the way, I need to cast something else. So they'll pick stuff up and then they move it all to the side. Okay? They didn't think about where they put it. They just had space, they moved it there. And then a week later, 2 weeks later, they're like, oh, we need to, assemble this thing, whatever. So they'll pick all the panels back up. They'll move them all the way across the manufacturing facility or outside, for example. They move them all outside. Then they reset them out there and they get ready to assemble. And a lot of times they don't assemble. And then finally they decide they're going to assemble. So they start assembling, but then they have to move some other stuff out of the way. And so you can see it's super inefficient to do it this way because you're moving panels and panels and panels. And there's 2 kind of components here to think about on why this is not good. One, you have product breakage. So a lot of these products are made to be picked once, maybe twice, right? Again, they're going to withhold if you keep lifting them. But the issue is that employees might not lift it correctly with the crane. So there's a designed angle that these different embeds are made to be lifted at. And again, there's designed shackles and lifting apparatus that is supposed to be used. A lot of times employees might not use the right one, right? That's just a safety hazard. But other times they end up bumping the panel with the crane and they're moving it, or they set it down and it chips and breaks out an edge of a panel. And it's not a big deal, right? It's just a little bit of here, a little bit of there. But the issue is when you go to assemble all this and you go to finish it, a customer wants a perfect product. So precast, most precast is just in the dirt, so underground, vaults, tubes, all that stuff. Or it's something massive like a parking garage or a bridge. And a lot of times you're not going to have people like right up with their face, like 6 inches from a door or a wall. And so most precasters don't realize it doesn't really matter. They don't think it matters. For our products, for things that are going to be architectural specifically, when a customer sees it, they want to see it's perfect. They don't want to see like a square edge where the roof is and all of a sudden a big chunk just blown out and you just paint it over it, right? So again, you have product damage from moving it multiple times. It creates more work. The other piece is just wasted time and labor of just moving these. So if you're paying a guy 10, 12, 14, 18 bucks an hour, $22 an hour, whatever you're paying him, depending where you live, I'm paying people to get in a crane, and typically if someone that operates a crane, they're typically going to be a little more skilled, and it's going to cost more. So there's that. You're going to have safety people to help move the panels, direct them, set them, and all that. So imagine 2 people at minimum, maybe 3 people to move a panel here and there. You're wasting more time and money, okay? So don't move panels a million times. I see this constantly in precast. This is kind of one of the knives in the coffin here, the final death of precast as a whole. They're just super inefficient. They don't think through that operations planning side. It makes a big difference. The other component here, as I mentioned, is having the supplies next to the panels. So one of the biggest losses in many precast plants, which they don't know, they don't monitor a lot of these things. And we had this huge loss and we try to work through this, but employees not preparing for the day. So what I mean by this is they would like get all ready in the morning, be all excited, grab their tools and go out there and grab a few supplies, and they'd get ready to, I don't know, let's say start painting. And they brought the paint and they got on, I don't know, their tool belt or whatever, and they're all ready, and they have their jacket on because it's cold out, and they're out there and they're getting ready to paint, and they go, oh, I need a paintbrush. So then they go back and they grab a paintbrush and they take that paintbrush and they go back to the building to get ready to paint. Oh, I forgot a screwdriver to open the lid on the paint can. So then they go from there, back to grab the screwdriver, back and forth. This was a consistent problem, and I've seen it when I've walked other plants. You watch employees walk around. So I've done a lot of plant tours as well on different companies. You'll see employees walking back and forth and back and forth. And it's not like you're carrying something really heavy, so you want to be safe and carry a couple loads. It's always like, oh, I missed a screwdriver. I missed, I don't know, a paintbrush, a roller. I missed a bucket to mix, like mortar mix in, for example. I forgot the water. I forgot, there's all these things they miss, and this costs you a ton of money in the long run, right? You think, well, it's not a big deal. It's a couple minutes here, a couple minutes there. Well, when you multiply that by the number of employees you have in over a month, for example, we started figuring out it cost us a ton of money. So one way we try to get around this is we had trainings and emphasis on, grab everything you need up front and do it. It's a training piece. And we would bought a bunch of buckets, like just the generic buckets. Home Depot has like orange ones, Lowe's has blue ones or whatever. You guys take a bucket, throw everything you need in it, throw a few extra things in that you might need, and take it all over and be done with it. Doing that training alone helps save us some time and money. So even though we sound kind of nitpicky and kind of annoying as management, we actually did see some increases in profitability because guys weren't wasting as much time going back and forth. And then on the employee management side as well here, you don't want to like nitpick your employees and try to optimize their time to the nth degree. So I'm a huge fan of, some leeway, understanding there's going to be some waste, for example, because when you treat employees like a manufacturing machine, essentially, where it's like you must build this in this much time, and there's no leeway, there's no understanding, employees start feeling like basically you're micromanaging every single minute, every single second, and a lot of times they'll just try to overthrow you, essentially, and they'll just be sitting around screwing around. So I've been walking our yard a lot when we had this, and employees would just be like hanging out, chatting, not working. And so again, you need that management component, but setting that culture is a crucial point for operations management here, right? There's things that are hard to measure. But setting a culture where it's like, you need to be working, you need to be efficient. Again, having a promotion schedule, paying people based off of productivity is a key here to help drive people. But also as a manager, trying to be strict enough to make sure people are still working, but also like not nitpicking things to death where it's like, hey, on this project you were over by 10 minutes or you're over by an hour. Try to let those things slide, but have some sort of threshold you set. Like when we, clear 10 hours or 20 hours over what we should have been for the entire project. So many of these projects take like 100 plus hours. Have some percentage, like 5%, 10%, 15%. But again, do multiple projects to make sure you understand what the average is, and then try to work your way to better efficiency over time without grinding your employees into the ground. And then to wrap up this whole podcast here, let's talk about the precast industry as a whole and why I think it's somewhat dead here. Most precasters essentially make ugly, plain, gray concrete. There's a need for this, guys. There's a need for pipe and vaults and bridges and things that are just plain ugly. But that being said, you can do better than that. And I say this coming now from living in Texas now for a while. When you drive around, for example, Dallas-Fort Worth, which is where I live, you'll see the bridges are painted. They're different colors, okay? The bridges here also have design. So I was driving yesterday and I noticed there was a bridge set up and there's like 4 pillars that hold up in rows. The first 4 there had like a leaf and plant design cast in. It was probably a 2-inch indent for the recess on the design work inside that pillar. And then you went back another layer and now it had like flowers and something else. And then a lot of times you'll have like, an animal or something on the last one. But they have like different designs, different colors. The Texas Star So a big logo of Texas you'll see a lot on bridges. Again, a lot of times they're painted different colors. The star is painted different from the background. And to make a note on this, I see a lot of precasters, they pour the mud, it's close enough, and they just ship it, right? Texas is really interesting, and I think precast is a little bit more complicated here, or at least a little better quality, because there was a retaining wall being built. So yes, they build these big concrete walls, they're like modular assemblies here, and they prevent the sound from going across the wall. So if you have houses behind it or businesses, you put up this wall, it blocks it, so the businesses don't see the ugly freeway. It helps block the sound as well. But in Texas, I was just amazed and surprised, because when you look at a lot of places, they just assemble this wall. It's all structural. They put it in place. It could be colored. It could be textured, whatever. And then they just leave. In Texas, though, there's guys on ladders on this massive freeway project that we kept driving by for, I think, like 6 months or a year. And there's guys out there with a bucket of mortar mix patching the bug holes. So if you don't know, in precast or in concrete in general, you have little air pockets in the concrete. You can't get rid of them. It's part of doing the job. You can change mix designs, and you can change things in the mix trying to make it less bug holes, so less of those air pockets, but you're never going to get rid of all of them in this, unless maybe you spend, I don't know, a ton of money on the concrete, something ridiculous. But you have to go back and you have to patch them if you want it to look good, right? It's still structural, it's still concrete, there's no big issue with it. But in Texas, I was watching these guys just months on end out there with this little bucket. They'd mix up, the water and the cement powder. A lot of times it's like, I don't know, it's called like Polyfast or Smooth Coat. That's what we used to use. I think it's a Dayton product. But you'd mix it all up, and then you'd smear it on the wall. And you don't just smear it on the wall like stucco and leave it, because it looks like crap. You smear it on, and you try to get it into the holes as best as possible, and then you wipe off the excess. Or you make it smooth enough. So Smooth Coat's good for bug holes. Polyfast is good for, larger issues like big chunks missing and all that. But you take the Smooth Coat and you put it on another product called Unicoat. I don't know why I'm marketing all this to you, but you put it on and you cover a lot of the bug holes, you wipe off the excess, and it makes the panel look completely smooth. For architectural precast, we did textured panels like barnwood and block and all that. You still have to smooth out the bug holes. If not, it looks terrible. So even with texture, you have to do it. But these are pieces I think a lot of precasters don't understand, because they're so used to their bread and butter businesses, which is that ugly gray cast-in concrete. And I hate to say it, but it's like they pour, you got a bathtub for them, you dump mud and it gets hard and everyone's super excited. Like, this isn't that exciting. Create something new, create something better in a product and a design here. One of the biggest struggles, though, for companies and why they're dead is you need different employees to do different things. So if you start getting into architectural precast and you want to do it really well, so for example, building restrooms here, you need someone who's really good at painting and hanging windows and doing locks. You also need an employee in the office that understands ADA, so design work. For example, you can't just, so this is something else that just drives me nuts, people don't understand. For a restroom, you can't just design a restroom yourself and then just build it, right? It has to be engineered. So then people say, okay, great, I'm gonna hire an engineer and they're gonna make me a restroom. Okay. Engineers don't know, A, what customers want, and B, they don't know all the rules a lot of times, like for example, ADA. That's not their specialty. So you have to have someone to design the product, to be competitive, to make a good quality product. Okay, that design work takes a ton of time. It takes an expert. It takes someone that's done this for years and years and years. You can't just go out and say, here's a building, it's square, it's block, or I'm going to try to copy someone else's. There's technology, there's small nuances built into these products that customers know about because we educate them over the years. The design part is like a huge component of this. It takes a lot of time to do this. You have to hand design everything, set it all up. Engineers also don't understand what embeds you use for optimization. So again, you don't want to use different embeds for every product. You want to use the same. Having a general understanding of what goes where, how many you need, for example, is crucial. Once you do all that design work, which is the vast majority, you hand it off to an engineer, and they will literally go through this thing in like, I don't know, a couple weeks, maybe a month at most, and they'll just do the quick checks of, yeah, it's done correctly. Right? Engineers don't technically engineer these products or like design the products. You have to have someone to do product development. So anyways, that's the whole process here. That's how you optimize things. Precast, again, one of the other issues, it's hard to get new talent into the industry as well. So most people that end up in precast and in concrete, they've just fallen into it. It's just an accident. They know somebody, their dad worked in precast, right? Their uncle worked in precast, a friend worked in precast. I mean, I had friends working for me when I was there. Again, a lot of people just kind of fall into it. The industry is not innovative. It's not exciting for the most part. And yes, there are some new products here and there. People get really excited about them. But there needs to be more innovation, more excitement. You need to bring in better talent again across the board. You need better manufacturers, better people that are skilled tradesmen, right? Building, for example, restrooms is actually a really unique set of skills, and we require people to be able to paint, cast, and assemble. And a lot of times we try to divide them up into the correct teams and do allocation of employees based on, optimal skill sets, for example. But even when you do like finishing, you have to be able to caulk, paint, hang locks, hang doors. There's a whole bunch of skills all put in this. Patching, for example. It sounds simple. Trust me, it sounds simple. But I've never seen a vendor of ours, anyone that's licensed to do this, even competitors, for example, do it full time. They just don't do it very well. So it's challenging. You have to get all your ducks in order. You have to get it all lined out. Again, if we could get new, exciting talent into Precast, that'd be great. And then people are going to ask here as a final wrap-up question, right? Dimitri, if it's such a dead industry, why is it still going? Basically, there's a need for Precast. There's a need to do it. Competition-wise, a lot of times it's expensive to set up plants and yards and get all the forms, right? There's a big upfront cost. The other issue with Precast is that most Precast is, I'm going to say, geo-located, right? Precast can't be shipped very far typically because it's so heavy. So most precasters are going to be local. And then you have big national chains. So I won't mention who, but they're big company names out there. You look at Precast. They buy out a lot of the little ones, and so they have this massive national footprint. But again, they make product in one location and they ship it close. So it's not super competitive in the fact that it's hard to get into a new market. So let's just say Dallas, for example. There's already a big plant here. You can't just set up a plant right next to them and then think you're going to compete unless you have really good advantages in product design and business plans and all that. Because a lot of times it just comes down to cost. And if someone already has a manufacturing plant set up and all those, operational components I've been talking about baked in here, again, that's going to be an advantage for them. So you need to set things up geolocation-wise, like spread them apart. Again, the precast restroom business, as I mentioned, is very unique. The fact that it's a precast concrete product, it is huge. It is massive. It weighs 20,000 plus pounds typically for a product. Again, some of these are like 60,000 plus pounds as well. They get pretty heavy. The fact that you can make that, ship it, and still be competitive and still beat people out across the country. And that's one of the reasons why a lot of these small precasters don't make it. It's too complicated. There's too many moving parts. Besides dumping mud in forms and it getting hard here, you have to know the assembly, the welding, the engineering, the product design, and finally all that finishing work that goes into these products. And then you have to build out an entire customer base as well. So that's kind of my wrap up here. This is why operational research, planning, working with employees, management sides is all super, super important to be competitive. And also here, this is why Precast I think is dead. There's not a lot of innovation. It's isolated based on your geographical location. There's not a lot of competition. And so it's just kind of floating along. People are happy doing the work they are. As infrastructure builds in different cities, you get business and you're excited and happy, but there's not a lot of kind of innovation drive behind the industry, which is just really unfortunate. But anyways, thanks for listening. And as always, until next time.